All right. Chapter 2 from Form 5, which is Chapter 7 for SPM, Chapter 2 Electricity. So for SPM 2020 batch, I think this chapter very difficult to tell stories, which part they will test, because this is a very common chapter. Why I tell you very common chapter? Huh? Okay, listen to me carefully, all of you. Okay, if you follow their structure questions, we follow, okay, right? In the last 3 years, 16, 17, 18, even 19, okay, there will be one question there, sure have, right? Um, you see, very common section B or section A, there'll have be one question. 2019, there's no question from section B and C for electricity, no question, right? 2019, they only tested in section A, all right? No section B, no section C. 2018 also no section B, no section C. So we should actually pay a bit deeper attention to this chapter. Kena tengok lebih sikit tahun ni, tak tahulah kan, okay? Okay, what are the things that I want you all to highlight for this chapter? Number one, the formulas. Make sure you know how to use your formulas properly. That's the most important thing. Make sure you know that even one single electron carry this amount of charge. All these are given during exam. Everything is given. When you manipulate your formulas, make sure you manipulate formulas properly and you know how to calculate properly. Units, jangan lupa. Common things I've noticed with most of you is that units are wrong. You don't put the proper unit, then you come and complain. Formula usage, especially series, parallels, make sure you know your formulas properly, right? Okay. So all this, we make sure you know. If you have any problem, you can still contact me. Okay. If let's say paper 3, question 1 or 2, or even suddenly they change question 4, paper 3, or any questions in section B or C, even the last question 7 or 8 of section A, paper 2, I'm talking about paper 2. See, for any experiment questions, when you look through this chapter, if let's say there's any experiment questions, okay, first thing, precautions, if they ask you during determination of EMF, all right, make sure the connections are tightly joined. If not, they will increase the resistance, overheating. Always avoid parallax error and make sure the circuit is disconnected immediately after you are taking any form of reading. So this is actually a standard precaution for any electrical circuit experiment. It's not only for this. So if you are given any sort of electrical circuit experiment questions, remember these are the standard things that you have to know. Make sure the connections are tight. Make sure that you place your eyes properly so you can avoid parallax error, and make sure you turn off your switch immediately after taking any reading, right? So use this for any other electrical circuit. And then when we talk about resistance, okay, always remember resistance should be V over I, or the other resistance formula should be resistance should be equals to resistivity times length of the wire over cross-sectional area. So resistivity type of material will influence resistance, length of wire will influence resistance, cross-sectional area will influence resistance, and also temperature. Temperature will influence resistance, right? So these are the things that you have to know, right? Type of wire, length of wire, cross-sectional area, thickness and thinner, okay? So these are the things you have to know. So make sure you know your terms also. When you talk about the coil, we mean the whole coil. When we talk about the wire, we mean the diameter of the wire. So two different things that you have to understand there. Okay, next, if you look at this study, common questions, a battery with EMF of 12 volt and internal resistance, okay, of 0.1 ohm. Calculate the value of a resistor that should be connected to the battery to show the potential difference at the battery to be 8 volt. Okay, read the question again, guys. EMF should be V plus IR. Right? EMF given 12 volt. V 8 volt. I, we do not know, but we know the internal resistance is 0.1 ohms. So the current that flows in this circuit will be berapa ohms? Berapa ampere? Betul gak? Hello guys?
Ya, betul.
40 ampere. So now you have to find the value of the resistor that should be connected to form or to get 8 volt. So V equals to IR, where the voltage here is 8 volt. The current found to be 40 ampere. So what is the resistance value? So 4 divided by 40. What we get? 8 divided by 40, sorry.
0.2.
0.2 ohms. That's the value of the resistor. So remember your formulas, guys. E equals to V plus IR, or E equals to IR plus R. These are the formulas. Okay. Next, you have Ohm's law. So I hope you will go through your revision on what is Ohm's law, what is EMF again. Please go through how to define what is electric current, what is potential difference, what is the differences between parallel and series electrical circuit. Okay, now let's look at draw graph of V against I to represent Ohm's law. If you want to represent Ohm's law, then right, see here, V against I. Mr. Chu, can you sketch on my graph?
Ohm's law, right?
First one, A.
With
Yep, correct. Thank you. Now, thank you, Mr. Chu. Now for EMF, Mr. Tay. Mr. Tay. Where is he?
Yes.
Sketch on my graph for EMF. Yep, very good. Okay, done. Betul? All right, thank you guys. Okay, anyone who got question now to ask? Okay, Tada. Celine, any question? Mr. Hong?
No.
No, thank you. Okay, next. These questions, the answers are at the back here. Okay, yep. All right. The filament in a filament bulb is made of resistance wire. When a current flows through it, it is heated up to a high temperature and begins to glow. Thus, light is produced. Write an equation for the power produced in the filament in terms of voltage across it and its resistance. Okay. So how to find the power produced? Okay, see what happened here now. Okay. We know that potential difference is the amount of work done to transfer per column of charge from one point to another. So this is the work done. Power is the amount of work done. Power is the amount of work done. But you have to give the formula across it, voltage and resistance. Wow. Okay. So W should be V times Q. All right. So Q should be IT. V I T. And then I should be V over R. Wah, banyak pening. So W should be V square over R times T, because I changed the I to V over R. So what is power? I use here. Power should be the amount of work energy over time. The amount of work energy is V square over R times T. So divide by time, right? So times 1 over T again. All right, this one, this one become 1 over T again. So I end up getting power should be V square over R. So they tell you, yeah.
Why don't I just use P equals to VI leh?
P equals to VI. Can also?
Then I become V over R.
Can also? Can also directly P equals to VI. So V over R, you get V square over R. Correct also? I purposely do the long way because I want you all to look at what is potential difference again, what's the relationship with the energy again, okay? So I go through the long part just to go through the excitement of using some of the formulas. Okay, that's number 1. Okay, thank you, Sean and others. Nalini, okay, not Nalini. I thought Nalini is in. Hey, where is she? Okay, that's okay. Eugene, okay, Eugene? Eugene?
Yep, fine.
Yeah.
Good.
Okay, very good. Next. Write another equation for the power in the filament in terms of current flowing through it and its resistance. Another one in terms of current and resistance. So in terms of current and resistance, okay, let's look at it. So VI, V equals to IR. So P equals to I square R. That's it lah. Done. Okay, guys. Next. The filament of a bulb is made of a very thin conducting wire that is. Okay, Aisha. Okay. Bye, Aisha. No problem. Okay. The filament of a bulb is made of a very thin conducting wire that is wound into coil. When the current passes through it, the heat raises the temperature. The filament starts to glow and produce light. If the filament bulb is connected to a 240 volt supply and the power rating of the bulb is 60 watts, calculate the resistance of the filament. Okay, power got, voltage got, calculate resistance. This I use the earlier formula. Okay, P equals to V square over R. So use that formula. The material of the filament must be chosen correctly so that the bulb can work properly. With a very high heating temperature, explain the best properties to be chosen as the filament obtained. Okay, let's look at the answer, B1. P equals to V square over R. So R equals to, V was 240 power 2 over 60. So you get the answer 960 ohm. Okay, next. The chosen material, another one, number 2. So the material of the filament must be chosen correctly. Okay, material of a filament. So melting point must be very high, longer length, and it must have the ability to be wound or to coiled around. Right? Strength also must be thin but cannot break, because it must have thinner wires so that it can have a higher resistance. All right? So most of the time it's tungsten. It's tungsten. Tungsten are used as the wire in bulbs. Right? Nichrome are used as the wires in heating element like electric kettles, shower, water heater, right? So properties almost similar, both also. Okay, last question for the day. Explain the best method of wiring in a house. All the house wiring must be parallel. Why must be parallel? So that we are able to turn on and turn off every devices in the house separately. Number 2, we are able to distribute equal voltage to all the devices in the house. Equal voltage. Number 3, the total effective resistance can be reduced. The total effective resistance can be reduced. All right. Higher current can be applied to the house. So banyak sebab why we are using parallel wiring system in the house. Okay. Parallel wiring in the house. Okay. The next part of the question I'll continue the next. Yeah.
Can repeat number 6?
Parallel, number 1, each devices can be turned on and off separately. Total effective resistance is reduced. We are able to give higher current, and every device able to receive the voltage 240 volt because all are parallel. So these are the reasons. Okay. All right. So electricity, we will continue again in the next class. No issue.